about C, and we've talked a little bit about the theoretical. Today what we're going to do is we're going to try to bring all of those different parts together, and we're going to implement in a practical way all these different aspects. So before the midterm, we were talking about the theoretical execution of languages. So for example, when we talk about a programming language, we talk about the multiple steps or the necessary steps to go from a string, an input string, into a piece of either executed code or some byte code that can be executed by the CPU. Does anyone remember what those steps are? So if I start with source code, if I have source code here, how do I turn source code into something I can actually use?
Compiler?
So we're going to use a compiler, but what does the compiler consist of?
Tokenization.
Tokenization, a tokenizer. Tokenizer, lexical analysis. And actually, when I did this before, I said this box is lexical analysis. Technically, both of these boxes are lexical analysis in reality, so this is lexical analysis as well. But this box is what I consider to be lexical analysis. They're both, but this is the one that we consider that we're going to use in general. This is I'm going to label as CFG. Let's think about what the acronym was first. CFG. The acronym does anyone know what CFG stands for? Does anyone do linguistics at all? Yeah. What is CFGs? No idea. Okay, so you don't do linguistics that much. CFG stands for context-free grammar. This is the basis of most of linguistics. Context-free grammar. Is it ER or AR?
AR.
Unfortunately, it's not context-free spelling. Context-free grammar. Let's have a shot at what context-free grammar means. What do you guys think that means? Give it a guess.
Grammar on a very small level, low-level grammar. So
Maybe. I wouldn't say it's on low-level grammar. Context-free grammar applies to all systems regardless of size. So for example, English has a context-free grammar that we use on a regular basis. The entire lexical analysis of English.
and it's like very individual assignment operators and stuff like that, not in a full.
So that's not true. It is the full thing.
Oh, is it open to our opinion?
Sorry?
Oh, no, it hasn't been.
Keep going.
That's in my right.
No?
Yeah.
Okay, well that's wrong. So good guess. Yeah.
Is there like a set of rules to define like the statements in, like for example in C, like defining a variable would have like a set of rules that it would follow?
So yes, when you say structure, when you say it's a set of rules, that is true. Context-free grammar is a set of rules that defines a language. Set of rules that defines the structure of the language. However, there's a little bit more than that. Because a set of rules that defines the structure of a language is grammar. That's what grammar is. What does context-free grammar mean? What is context?
Something for a specific occasion.
So something that defines a specific occasion, right? And so if we say if it's without a specific occasion, context-free, without a specific occasion, what this means is without a specific meaning applied to the language, without a specific instance, without a specific meaning. So this is grammar that applies to a language. It doesn't matter, this is true for all languages. That works without a specific meaning. Now, natural human languages aren't always context-free. You can't always make a context-free grammar for human languages. And this is because human languages are retarded and we make up exceptions to rules all the time. English is horrible. I before E except after C, except for the other 40 times when that's not true, right? So we can make a context-free grammar for English, it's just going to be broken a bunch. However, for programming languages, what we do is we define the context-free grammar. Once we've defined that context-free grammar, we never allow it to be broken. It'll always continue to be the same. But it has to be in general. And the other word that we want to talk about is it's without semantic meaning. So semantics are the part that give words the actual meaning. So for example, I could say, Scott sits on blank. And I could put that blank, I could fill it with any word. Like I could say Scott sits on the table, and that makes sense. Scott sits on the desk, Scott sits on the chair. Those are all valid sentences. I could also say things like Scott sits on the horse, or Scott sits on the pumpkin. Those are also valid things. But once you say something along the lines of Scott sits on the run, that no longer makes sense. Because the run, or run, Scott sits on run is better than the run, because the run works actually. Scott sits on run no longer works because run is a verb, not a noun. Right? And so when we talk about context-free grammar, we're talking about the things such as noun, verb, noun. Subject, verb, object. Remember we started talking about subject, verb, object? Noun, verb, noun? Noun, verb, noun makes a valid sentence, right? Scott sits on the pumpkin. The pumpkin sits on Scott. Both of those sentences are strange, but they're both grammatically correct. And so what happens when we build these context-free grammars, we're doing it without a semantic meaning. It means that all we're doing is verifying the grammar is syntactically correct, or grammatically correct. It doesn't tell us if the meaning makes sense in the slightest. So for example, we could say, a man walks on the moon. That makes sense. We could also say, a man walks on the sun. One of those sentences doesn't make semantic sense. Context-free grammars do not determine if semantic sense has been made. All it makes is it grammatically correct? Right? So when we do the tokenizer, which splits up everything into tokens, for example, when we think about the C or the C++ or the Java sentence, int x equals 3, the tokenizer is going to split this sentence up. The tokenizer is going to split it up into something with maybe the integer here, the x, the assignment sign, the 3, and the semicolon, perhaps. Maybe that's what the tokenizer does. The context-free grammar is going to be able to tell us if that's a grammatically correct sentence. It doesn't tell us if that's semantically valid. What does semantic validation mean? If we could semantically validate this, what would that help us with? What does it mean if something's semantic? Go for it.
Oh, I mean, when you're asking what it would help with, is we wouldn't be able to compile like mismatch types or anything.
So like for something like this, right? Float x equals 10.0f, int x equals 3, something along those lines, right? Where we're trying to use x twice. This context-free grammar won't check this because it doesn't know the difference between x being a valid sentence, because that's a valid sentence for x and that's also a valid sentence for x. However, in C, this is not valid. This is not valid in Java either. And this is not valid in those two languages, not because of the grammars, but because of the way the language must be used. Semantically valid sentences typically also have a valid meaning. Can we make a grammatically correct C sentence that has no valid meaning? So when I say that, what do we have to know first? Or let's not do it with C, let's do it with English. Can you make a grammatically correct English sentence that has no valid semantic meaning? Go for it.
I have muscular teeth.
I have muscular teeth. It's a good sentence. I have muscular teeth. That is a grammatically correct sentence in English, have muscular teeth. But this does not make any semantic sense. How do we know if it makes semantic sense? So it's not just that it's not imaginable, but so that's part of it. But how do we even try to figure out if this makes semantic sense? How do we go about that?
Experience.
So when you say experience, what do you mean?
You have to know what each individual word means.
You have to have knowledge of the parts of the sentence, right? So if you don't have knowledge of the different parts, like if you don't know what teeth are, then you can't make a guess at whether or not this is semantically correct. If you don't know what muscular means, right? Without that extra knowledge, you can't make that assessment. When we look at some things like C, for example, what does that operator mean? The assignment operator, correct? So the compiler must have knowledge of what this operator means. And if it has knowledge of what this operator means, it can begin to figure out if it's a semantically valid sentence. For example, if I have x equals 3, semicolon, like so, the compiler has to know something about that 3. What does the compiler know about this 3? It's an integer, right? It's a number. It's a number type. It could also be. Could this also be a float? Yeah. Could this also be a double? Yeah. So the compiler has to know something about this 3 here, and so it'll know that this 3 has those values. It also must know something about this x. What must it know about this x? Sorry?
The type?
It has to know the type about this x. Because if we don't know the type of this x, we don't know what to be doing in this sentence. This is for C and C++, and Java, and any other compiled language for the most part. And so, for example, earlier in the code, if we have something along the lines of string x, like so, this is no longer semantically valid. So this would be a semantically invalid, grammatically correct sentence. This is the same as saying I have muscular teeth. Does anyone not see why these are the same problems? This one here because teeth can't be muscular. This here because strings cannot be integer values. Right? All right. We get to a weird sticky situation, however, in C and C++ versus Java. So for example, in C and C++, I can absolutely say this, where in Java I cannot. Because in C and C++, char x means that x is a data type that I can actually break the abstraction on and make it an integer, and assign it the integer value of 3. I don't know what that character looks like, but it's a character. Whereas in Java, I can't break that abstraction. And so it depends upon the language that you're working with whether or not you can actually do these assignments. Yes?
I just have a question about why that would be valid, because I've done something similar for naming files within a program, and say like, I want to name the file 3 something because my target number is 3. Let's name it.
So that's where you're doing, let's say we're in Java, for example, in Python. So let's use, okay, so Python's an entirely different place, but let's use Java as an example because everyone's familiar with Java. Let's suppose I have this string x. If I try this assignment, Java won't allow this to happen because it doesn't know how to assign the 3 to, the integer value 3 to the string. However, if I do this, like so, Java or Python in this case here, what is that operator? Concatenation, right? And now Java and Python both know how to concatenate an integer to a string. And the result of a concatenation of an integer and a string is what type? A string. So the result of this is a string, not an integer.
Would 3 be valid?
With single quotes?
Yeah.
In Python, yes, not in Java.
Or not in Java?
Oh, maybe in Java, yeah. So I take that back. If you put single quotes around there, that'd still be valid.
That's what I was wondering.
Yeah, because that'd be a character concatenated with the string. The character 3 concatenated with the number, with the string hello.
Oh, what if you sorry, what if you didn't have hello, but you really just wanted a number string?
So if you just wanted the number string like so, in Java, if you did this, it might, I don't know if Java will accept this. I haven't tried this
Double quotes.
forever. Huh?
I think double quotes.
Double quotes would definitely work because double quotes mean it's a string. But can Java accept a single character? And I don't know that. Python will. But that's because Python doesn't actually have data types for its variables. Yeah. And so this is where we get into all these different parts of all these different languages have different ways of understanding the semantic meaning, which goes into the next step. We have to determine the semantic value of these sentences. And the way we do this, the way we're going to do this is we're going to use an interpreter. We're going to have an interpreter. Now, different languages are going to do different things at different steps. For example, C and C++ actually does the integer assignment and the integer values in the context-free grammars. It doesn't do it inside of the interpreter or the code generator. If we don't talk about it as being an interpreter, we talk about this as a code emitter. And if you're really interested in how compilers work, I recommend that you get the Dragon book. There's two, so the first and the second edition, they're both the same thing essentially. The second edition is better. But, the Dragon book, if you search Google for the Dragon book, there's one of them. And it's the de facto compiler book on how you write compilers. We're only going to worry about these three steps, and we're only going to worry about them at a relatively high level. We're going to talk about these two more so than the interpreter. What we're going to do today is we're going to figure out how to make all of this happen. And what we're going to do is we're actually going to start at the source code level, or we're going to figure out how to do the source code level, and then ask something else to do those 3 steps for us. And then that other thing doing those 3 steps is going to be the part that's going to be the Lua interpreter for us. And then what we're going to do on Thursday is we're going to actually start looking at context-free grammars for C, C++. We're going to start learning what parse trees mean and how we actually build from a sentence, how we actually start looking at it in terms of a language being built. But before we get there, we're going to look at how we can approximate this by asking somebody else to do all the work, which is ultimately what you always want to do. But ask somebody else to do the work, and you take all the credit. Right? Okay. So those are the parts we're going to do. We're going to do all those steps. The only thing that we're going to have to do is we're going to have to get we're going to have to get the source code, and then we're going to have to ask the Lua interpreter to do everything for us. Okay. I'm going to start by identifying a couple of, we're going to start by doing this in C. So what we're going to do is we're going to write a C program that is going to get our source code. Once it gets our source code, it's then going to pass that source code into the Lua interpreter. That's what we're going to do with this program. I'm going to show you where to find this information online when you're looking up this stuff online, or if you've already got the book has all this information as well too. But we're going to look at the Lua version for this. The first thing we're going to have to do when we're going to start using the Lua interpreter in C is we're going to have to include the C headers for Lua. So the C headers we're going to use stdio again, like always, kind of include stdio. And then we're going to use the Lua header. So we're going to use the pound include Lua. We're going to use double quotes, lua.h. Now, just using the lua.h, we're going to use the double quotes. That means that this is a non-standard include header. So the lua.h is going to be a non-standard one. That's why we use the double quotes. And we're going to have to tell the compiler where to find those includes. And I'll show you how to write that, how to do that today as well. Then we're going to say pound include 2 extra helpers. The first one is going to be lua lib.h. So the Lua library, these are going to be a helper library. These are going to be things that help us. So Lua.h without the helper library is exceptionally hard to use. We're going to use an extension helper library, which makes it even easier to use. We're going to use pound include, and I'm pretty sure this is a typo that never got fixed, which is lauxlib.h. L-A-U, not L-U-A, lauxlib.h. This is the extension library, and I don't know why it's lau instead of such as like. So these are the three ones we're going to be using. These are the three helper files that we're going to be using. If you're trying to do this in Windows, there's some special setup that you have to do to get Visual Studio to compile these things. If you're running it on Linux or on Rohan, I'll show you how to do the compile step. All these things will also require that we link against a library. The same way when you try to do math, you have to do a -lm, right? In this case here, we're going to have to link against a custom library, and we'll show you how to do that link as well. -L. We're also going to have to build. We're going to have to do what's called a static linking. We'll talk about that later when we get to it. We'll do some more stuff. More magic at the command line when we're doing the compile stuff. So these are the include files. And then we're going to write the C file. The C program is in general, as in the standard way. So for example, int main. Now the first question. Where do we want to get our source code from? Where would be the easiest place to get the source code from? So files would be the second easiest place. Standard in, right? Is there any reason why we can't just type source code into the standard in? How does bash work? Where do you type your stuff? If bash is a C program, where are you typing? Standard in. So when you type in grep to standard in, and then bash interprets that line of code, that's exactly what bash is doing. So what we're doing is we're building a command line interpreter for Lua. That's what we're going to be doing. So we're going to get it from standard in. What do I need to use from standard in there? How do I get space for standard in? I need a buffer of some kind. So I'll have my char buff. Let's do 256 characters for now. That might not be enough. We'll figure out whether or not that is enough more or less later. After we have our char buff, what we're going to need is we're actually going to need the Lua state. So when we do a Lua programming, we're going to talk about a Lua state. So we're going to talk about the Lua code and the Lua side of things and the C side of things. We want to be able to go between the two of them. In C, we're going to define the Lua state. So I believe it's Lua underscore state with a capital S. I believe it might be a lowercase s. We'll look at this when we get to the compile side. This is going to be a pointer, and I'm just going to call this capital L for the Lua state. What's going to be inside a buff?
Characters.
Sorry?
Characters.
Characters, right? What are those characters going to represent? The source code. So the buff is going to be the source code. What is L going to be? L is the Lua state. What does the Lua state mean? What is a Lua state?
I'm not sure, but if I had to guess, is it like a context?
And it's more than just a context. And what is a context if people don't know what context means?
It's like kind of like a working space for the I don't know how to explain it.
So a context is a bunch of memory that a different section of code can use. And so, for example, Lua state here will be all the memory that Lua will be using. So, for example, if I say x equals 3, where does that x store? And the answer is it's going to be stored inside the Lua state. The other thing that Lua state is going to contain is also going to contain all of these parts. So it's going to contain our tokenizer, our context-free grammar, and our interpreter for Lua. Lua state will contain all of those. After we've defined our Lua state, does defining a variable mean that it's ready for use? No. So what we're going to do is we're going to assign our Lua state to a new Lua state. So I think this is Lua. This is where it's whether or not it's in the extension library or not. Lua L new state, I believe is what it is, with the arguments. Just like that. And it's either Lua L or Lua X, and we'll look at this as we're going through it. My memory on which one of those it is shabby, so I'll have to look it up. After we get our new state, what do we want to do? We don't have an idea. So when you say malloc, what do you mean?
Defines memory or to be able to use the
Ah, so malloc some space for Lua to be using, right? That's what this new state does.
Okay, that's what I was
Correct. Yes. So your idea when you want to, because I said this Lua state is going to be memory for the Lua interpreter to be using. That's what the new state does. Is it allocates the space for it. Right. And it returns the new state, the L of the Lua state that we're going to be using. What do we need to do now?
Start taking in source code.
Sorry?
Start taking in source code.
So we need to get some source code, right? So let's just get a single line of source code. Take that single line of source code in. So the way I'm going to do this is I'm going to use a scanf. I'm going to use, it's the percent hard bracket / caret, or is it caret and forward slash? Caret forward slash. Up caret forward slash new line right caret, like so. That'll take in an entire string or an entire line. Read until the new line character. I'm going to store this inside a buff, like so. Now what do we want to do? So now we've gotten our source code in. Now we want to pass our buffer to our Lua interpreter. Our Lua interpreter includes all of those things. So the way we're going to do it is we're going to tell Lua to do this string of code. So we're going to say Lua, Lua L actually, underscore. Lua L underscore do string. I think it's all lowercase. Do string. The first argument is going to be the Lua state here that we want to be operating on, which is L in this case. The second one is going to be the string that we want to be using, which is buff, like so. I'm going to then close my Lua state. Why do you think I need to close my Lua state? I'll close before I return 0. Say it again.
Prevent memory leaks.
So why do I need to prevent memory leaks? Because you're right, but why is this? What is this Lua close doing that's going to prevent the memory leaks?
Free memory.
It is freeing memory, but why? Why? It's just a Lua close, and I'll do it up on the overhead as well, and then it returns 0. Why do I need to do a Lua close here? Why do I need to free memory? Why do I need to free memory?
Because you're gonna take it another line.
So no, that's not the reason why. So why? What does new state do?
Oh, no,
So what do I need to do?
that's it.
Free it. So I have to do my Lua close, and I have to free it to free up the extra memory. Why do I need to do that? Because I know that my new state is allocating memory. If I don't free the memory that the new state allocates, it's going to be a memory bug or a memory leak. So that's the reason what I have to do. So I'm going to pair those guys. For the same reason, when I open a file, what do I need to do after I use that file? I need to close it so I can free the memory that was allocated for that file. So a lot of things are going to be open, use, free, and particularly in C. In Java, you just say open, you use it, and then you stop touching it for a little while and it gets freed itself. And that freeing itself is that memory manager. Lua itself has an inbuilt memory manager, but the C version does not, because when we're in C land, we're still in C. When we're in Lua land, we're in Lua land. The Lua has an inbuilt memory manager. Any questions about this so far? So this is it. This is essentially a Lua interpreter. There might be one more line right here. We'll have to look at that. That's whether or not we have to open the libraries for it. But essentially, this implements all those things over there. This do string here in the middle is the part that does the tokenizers, the context-free grammar, and the interpreter. And then the source code gathering is the one that's being done by the scanf. If we had a file, we could actually just ask Lua to do one entire file all at once. We wouldn't have to actually scan the line by line. But if we had a file, we could do a fscanf, on each line inside the file and pass that into the Lua interpreter line by line. So let's go and take a look before at the information that we're going to look at here on the internets. If we type Lua into Google, the very first option should be the programming language Lua, lua.org. If we go to the programming language Lua at lua.org, there's a bunch of things here. If we start at documentation, documentation is going to describe the language. There's the reference manuals. This is the one that I had the optional book for class. This is the one I'm talking about that has all the stuff in it. This version of the book is available for free online. First edition is available online. So here's the first edition of the book available online. So this book, the first edition, is primarily the same thing. However, it's no longer true. The C API, the application programmer interface for the C version, the C stuff we've looked at, is a little bit different. So what we're going to do is we're going to go through this first book here. If you look, you can read about all these things. For example, hey, look, lexical conventions, standalone interpreter, types, expressions, statements, functions, etc., etc. Talks about the entire language, data structures, metatables. We're talking about most of this stuff. If we go into the C API, we go to the first example of the C API, and this is the example version. So they're using string.h, so that you can use a string instead of a char buffer, but we don't have to really. They've defined their buffer. They have this integer error that they're going to be using, which we're not going to be using right now. We'll use it later. This Lua state open, Lua open. Then they open all these things here. If we go up here and we take a look at this big red code here, it says, this is for Lua 5, which is no longer true. 5.1, which is the one we're using. They use Lua open _* for a single call with Lua L open libs. So we can actually replace all of these with the Lua open libs. I think there's also a new state function that we can use, which actually does both of those steps at once, which is what I believe we used here. Then we have this stuff in the center here, this while loop here, and we'll take a look at what this while loop does here in a second. And then we close the state and we return 0, which is what we did here. What do you think this while loop does? Without reading it too much, what do you think it does? It gets a line of code, it gets a line from the standard in, and then it does what? What does it do? Something. What does it do? It executes it. It executes it in the Lua stack, in the Lua system. And so this while loop here, what it's doing is it gets a line of code, and then it executes it in the Lua system. When it gets a new line of code, then it executes it in the Lua system. Let's see how they did it. We have this while loop. Why do you think they have a while loop here? We can get a lot of lines of code, right? fgetS. fgetS is another way that we can actually get an entire line of code, or an entire line, not code, an entire string line from the standard in without having to use the scanf. It does the same thing. However, fgetS also has some safety measures. So for example, we can use buff, and we can put the number of bytes that it can read here. And it uses size of buff, because it knows the size of buff tells it that it's 256 bytes here in this case here, because that's what the size of does there. Off of the standard in. We could also use this fgetS on a file as well, if you opened a file before and put a file there instead of standard in. This size of prevents you from doing what? What's that called? Buffer overflow. Buffer overflow. So what here we're saying, hey, I have a 256 byte buffer. I can get 256 bytes. If they try to type more than 256 bytes, it won't get more than 256 bytes. We don't want a buffer overflow. We don't want a stack overflow. So that's what that does there. Instead, with our scanf, what happens with our scanf if they type more than 256 characters? Buffer overflow, we're screwed. So we might want to change to this FgetS here. And then it does this thing where it does a load buffer or pcall. What load buffer does is it sticks the string into the Lua interpreter. It sticks it into the tokenizer and into the context-free grammar. And then the pcall tells it to execute that buffer in those places. When we say doString, it's essentially doing those two operations. It's doing the load buffer and the pcall for us. What's happening here? Load buffer or pcall. What does that mean?
It's like setting error bits on that error message.
So we're not using a bitwise OR, so it's not exactly
my bad. I thought that was
bitwise error,
bitwise OR.
but it's a straight up OR. Load buffer and pcall both return true or false, which is either going to be 0 or 1 in this case. But they return true or false, and so if load buffer returns false, what does that mean?
There's something wrong with the line.
There's no error when it returns false. What if pcall returns false? Means what? There's no error, is what that means. And so if load buffer and pcall both return false, that means that there is no error, and false or false is false, which means an error is false, and so we don't have an error situation. And so this is just checking for errors in either the context-free grammar or in the interpreter itself. And then this is what it's doing in the error situation. It says, hey, there's an error. Let's get rid of that error from the stack. We don't actually need that error handling.
The load buffer just puts
Puts the string into the tokenizer, ready for it to be called in load. It kind of it primes the tokenizer. If we just called pcall, it would try to call the tokenizer on nothing, as if nothing was there. And so when we do the load buffer, it puts the buffer into the tokenizer, so we call pcall. It'll shoot it through. And we use doString instead of the buffer and the pcall, which do the exact same thing. If you read through here to tell you about how this all works and what's going on here, and you can go through the rest of this, the C API. There's a bunch of stuff in there. We're gonna go and do this on. Let's call this Lua. Let's call this interpret int interpret for interpreter.c. So this is going to be our C interpreter. We're going to do essentially those same things that they did before. I'm going to simplify this a little bit. I'm going to show you how I simplify coding in PuTTY and in C. So I'll go and copy that, and I'll right-click in PuTTY, and that automatically pastes for me there. Okay. We'll do the same thing here. Go up and fix these includes so that they're all the right. tab is in the wrong place. Let's fix that. We'll say Lua L open libs on L, like so. According to this guy right here, which will allow us to do all the open libraries instead of these guys right here. And then we're going to do something similar to that. Let's just do our single scanf and then our single run, and then we'll do we'll do that while loop later. Scanf. And we'll go and push that. We'll do a Lua L. I believe it's Lua L do string. If that doesn't work, we'll take a look at that.
Should we close it first?
Yes, we should close it first. Thank you. All right. So we're not doing the while loop. We're only going to scan one line, and then we're going to do that string instead of doing the load buffer and everything first. So when if I try to compile this here, all it uses the hard brackets. It's okay. We can use the hard brackets. GCC is fairly relaxed about those things. When I say GCC interpret.c here, this lua.h, lauxlib, and the lib.h things are no such file or directory. What this means is that we don't have the necessary include files. And so what I have to do is I have to actually include those files as well. So I'm going to use this by using the dash capital I. I think the order matters. Let me do the dash capital I first. So dash capital I, the way I'm going to use this is I'm going to use my directory. So this is going to be the home MA. So this is the way that you guys are going to be compiling it with the Lindano. It's going to be inside of Lua, I believe, headers, like so. So I'm going to do the GCC dash I with the home MAJ Lindano Lua headers, and then there's no L in there for the headers. And then I'm going to say interpret.c. So that dash capital I is telling GCC, is telling the compiler where to find these additional header files. What are these additional header files doing? What are they doing? They are giving me functionality, more things, right? Header files in C and C++ are defining the new data types, is essentially what they're doing. They're defining new data types, they're defining the functions. They are defining the things that the tokenizer and the lexical analyzer use when we're using the context-free grammar to determine if the things are grammatically correct sentences. So for example, in my code, I have this thing called Lua state. I have this Lua state thing, I'll just open it up here. You see this Lua state thing here with the capital S, star L, right? That Lua state, is that a variable that that type C regularly knows about? C doesn't know about that type normally. So I have to tell the compiler about that type, such that when we're doing context-free grammar, it knows that Lua open is returning a Lua state, and variable L is of that type, so that that is a grammatically correct sentence. So we have to tell it about that type, and that's what these include headers are doing. So now when I do this compile this step, you notice that the error is different, correct? Because now we're able to find all those different parts. Now what is the problem that has happened? It says Lua L open libs, p call, close, open, load string, etc., etc. It says first reference in file, whatever the hell that is. What is this thing? It's a temporary file. This is called the object file. And so in the compile step, there are many stages. For example, in 237, you guys talk about doing the assembly language file to ones and zeros. In that process of going from assembly language to ones and zeros, you go in through what's called the listing file. And that listing file has all the memory locations. And it has all of the byte codes, and it's expanded all the macros. Do we ever use a thing called load string? We never use load string. Like, what is that? Where did that come from? P call K, did we ever use that? Those are two things that we never used. However, during the compile step, those were expanded into new things and then put into the object code. And this is that temporary object code. This is like that listing file you guys were looking at in T37. If we actually, I don't know, can we actually look at that? Let's see if we can still cat that file. var temp cck13. No. jfe.o. No, that doesn't exist. Okay, so that file's gone. But that's the temporary file that it was using to as the object file. And so this one it says we can't actually find those.
It's got double slashes in
And double slashes don't matter. We could try it, or they shouldn't matter. Here, what step is this breaking at? So this is breaking in the open list. What step in our concept here? Is it breaking at the tokenizer, at the lexical analyzer, or at the interpreter? Which of those steps is it breaking at?
Interpreter.
It's breaking at the interpreter step. How are you guessing that? It's a good guess. It's true, but how do you know that?
It's already broken down into parts.
It's already broken down into parts, and we've already determined that the grammar is correct. Let's demonstrate this proof to ourselves. We'll go in here. Let's make this else. No, that's going to break the same place. Let's make this with no equal sign there. Error. Syntax error before Lua open. What kind of error is a syntax error? A what?
Tokenizer.
So it's either the tokenizer or the context-free grammar is where those two places would be breaking. I would say it's probably actually the context-free grammar because syntax is a form of grammar in this case here. This is the code emitter part breaking, and the way we can tell this is that what it's trying to do here is it knows that this should be grammatically correct because the header file has defined this thing called openlibs. And even though it's defined it as a thing that should exist, it doesn't know where this thing is. And so it says, oh, this is correct grammar, but I don't know what it is. It's kind of like the sentence, when we made the sentence, my teeth, or I have muscular teeth, right? It said, oh, that's grammatically correct, but it doesn't know the definition of muscular. This is a grammatically correct call thing because that's supposed to be a function, but I don't know what that is. And so it's breaking on the semantic step. The way we're going to do that is we actually have to tell it where these things are. And so what we're going to do here, this is the same problem we had with the math library. We're going to actually link with our library into the location that our libraries are. So where these files, or what those things actually are, the way we're going to do that is we're going to link to home, MAJ, Lindano, Lua, lib, I believe. Yep, Lua. Lib, like so, with a forward slash. Oh, no input file. Okay. Let's see. Maybe it's a lowercase l. There we go. Okay. So now when we use the lowercase l here, not the capital L, that's telling us that we want to look for the things that we don't know about, the definitions that we don't know about. Let's look for those things in this extra library folder. And so when we tell it this extra library folder, it finds all of those things. And then it says LD fatal, library L home, blah, 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 lib, not found. Oh, maybe I have to give it the actual lib, sorry. .so. Let me try .a. Maybe this one is the dash capital L. Let me try this one. Yeah, there we go. One of those is one of them. The other. Oh, that's not right still. Come on.
Would it matter if that includes wearing quotes or brackets?
It shouldn't. We can try that though. That shouldn't be the problem here. We'll give it a shot though. If this doesn't work, we'll go look at my cheat sheet. And then go it up to the side. That's the capital L. No. Let me look at my cheat sheet real quick. I'm sorry. Almost done. Sorry about that, guys. You figured it out?
My
You're sorry.
310.
Okay. So the file.c has to be, okay. This is the step that I'm missing here. So this is the part that I was doing the dash capital L correctly. I was just missing the dash little part there. All right. So it is supposed to be, the order does matter. The interpret C has to be in the beginning. This is supposed to be a dash capital L here. Interpret.c. And I also want to do the dash L Lua. So what I'm saying is, in this case here, let me make that bigger so you can see. Yeah, okay. So when I say the dash L Lua here, that says let's link the Lua library. The dash capital here says let's go find that Lua library in that folder. I was pretty close. When we run it this time, now we should get a different set of errors. When we look at all these different errors here, what is the errors that it's finding now? What are all those errors?
Math library stuff.
Math library. So what should I do?
The math library.
Link the math library. So I'll also do a dash capital LM, which will link the math library for me.
LM together.
Yeah, we'll do the catch. You shouldn't have to put the no spaces there. It's saying that there's no errors there. Dash I, header,
LM together.
S error. Sorry?
LM is
LM together.
LM together. I just did the LM together. The Lua. Is that one in the error above before here too? It was. Lua open. Let's look at the other. Am I missing something?
State.
Lua L. Let's do the Lua L new state. So this is one of the problems when you use the older textbook stuff. Lua L new state. There we go. Problem solved. So make that the open into a new state. Now we have that, and I wrote to a.out. So now when I try to run a.out, fatal. Lua.so, no file or directory. This is the next problem we have to solve, and the way we solve this is when we compile it, we have to tell it where that Lua library is. This is the last one. J, Lindeno, Lua. And this is going to be inside lib as well, like so. Now I compile it that way, and now when I try to run it, now it'll run successfully. Now I can do something like print hello world. And it returned hello world. Did I program? No, right? So this hello world, what's printing that hello world? Lua is printing that hello world. If I run this again, I can say something along the lines of x equals 3, print x. And I printed 3. Right? If I do the same program and I say print x, it printed nil. The value of x is nil. One of the things in Lua is all variables are valid, they just might have the value of nothing. And the value of nothing is nil there. I can say x equals 3, x equals hello, print x. What's it going to print in this case? Hello. So that's the Lua interpreter working. So the Lua interpreter is able to tokenize each of these parts, and then it's able to use the context-free grammar to validate that all of these are correct sentences, and then it's able to interpret them for me by using that doString section. This is currently not going to run. It only runs for one line, so I can't do more than one thing. That's the reason why I'm always running like every single time. Like for example, if I say print x in this case here again, that's the wrong x. That x is not hello because it's a completely different Lua state, right? Because when the program starts, we create a new Lua state. Any questions about that? So all of that stuff up there is chilling inside of the assignment for you, right here inside of your assignment. So I've shown you how to do all this stuff here when you're doing the compile steps. You don't have to worry about memorizing that compile. I walked you through all the different parts of why that's hard to do. The assignment is essentially to do this, and then to write a Lua program that runs on top of this, and then to write a bash program that automatically grades it, automatically validates it. Any questions about that? Yes?
Do you mind going back to the Pico editor?
Mm-hmm. If you don't have this copied down, or you don't remember this, or you can't find it online someplace later, there should be an example of this if you search on Google long enough to find the correct answer. It's also in the red book or the orange book if you have the red or orange book. If you don't have either of those books, you modify the version that's online for free, or you can find the other version that's online for free that isn't the book.
That's just what do the error checking.
You don't have to do the error checking part. Like in this case here, we could do the error checking part if we look at the actual definition for the do string. Oh no, we have 15 minutes right here. So we look at the actual definition for the do string here. This is inside of the 320. This is inside of Lua. Yeah. We look inside the headers here, and we grep do string. No, none of those are in there. Oh, that's not how it's spelled, doString. Grep doString. That's inside of allowxlib.h. So if we pico allowxlib.h, and we go to doString, this is what the doString is actually defined as. So we can see that doString is defined as the load string and the p call, which is exactly what the previous code was. And so if you want to do the error checking, I can take the return value of the doString, which is the same thing that it was before for the first program. So if I go back to my CS320, if I want to do the error checking here, I can actually just say if or int error up here. Well, I have that error up there already. It's say error equals that guy, the same exact way that it was defined in the first part. You could do the while loop around there. I do recommend that you do actually add the error checking, because if you don't and you type an error or you type something that's wrong, so for example, if I run my program here, wherever my program is, and I do something that's wrong, for example, print hello instead of print, it doesn't help me. That's not correct. It should have printed hello. I got no error. I got no response back from the Lua interpreter. The Lua interpreter failed inside of either the tokenizer or inside of the context-free grammar or inside of the interpreter, but I got no information back about why it failed. And if we implement that part that they had before, which let's go, we have a little bit of time. We can actually implement that right now. If we implement this part right here, it'll actually do that for us. So let's go ahead and implement that. We can do the while loop here.
Will the while loop allow you to also enter multiple lines of code?
Say it again.
Can you enter multiple lines of code?
Yes, we'll do that with the while loop right now. Okay. So we'll do the fprintf. We'll print a standard error. Standard error is like standard out. It just is the standard error. It's a different file. It's a different output. It shows up on the screen unless you tell it not to. We're going to print this as a string, which is the Lua toString of All this, for now, just copy this garbage here that exists. What all that means and why it's there isn't important yet. I'm going to say while one here. Where's my compile center? What I missed?
Double quotes under
Oh,
the stem.
So now if I do something wrong, oh shit. What happened? My scanf. I don't have a space after my scanf here. That's what happened. So let's talk a little bit about this. This you would have learned this in assignment 4, but since we're not doing this in assignment 4, talk about this. That error right there this is what happens with no space. If I have no space on either side of this scan right there, this is what's going to happen. This is what the response is. What is happening when I do something like this? Print hello. What's happening?
Infinite loop.
It is infinite looping, but why? Well, there is a delimiter. The delimiter is the new line character in my scanf. But why is it continually running?
Can't handle white space.
So it can't handle white space. So what I've done here, the way that scanf works is that it will read until the new line character, and then it does not read the new line character. So if we think about this as a file, when we think about how files work, if I have the text hello and then a new line character, files work by having a file pointer that starts at the beginning. So for example, the file pointer starts at the beginning, and then I read the word hello with the scanf. The file pointer will now point here. What does that scanf say to do? No, it says read until when? Till the new line character. Well, how far is it till the new line character? No characters, because it's already there, right? So the scanf just reads nothing. Buffer is unchanged. What's left in buffer? The previous call. Well, then it reads the new line character. How far until the new line character? No characters. Continually. When I put a space after that, the new line character there, this says read until the new line character, and then skip all white space. The new line is considered white space. And so, for example, if my file said, hello, how are you, question mark with the new line there, the skip all white space will skip the file pointer up to the next location, even if I had a bunch of white space in the beginning. And so that's what that new line on the end is. Another one that would also work is if I put a space there in the beginning. Both of those solutions would fix this problem. Put that new line space there, recompile it, run it again. Now I can do print hello. You can see the print. Print hello. Not printing hello, right? That's unfortunate. What's going on?
You have your
There's the hello. Oh, it's the new line character. It's that fucking space again. Let's put the space in the beginning. Let's do that. Print help. There we go. Okay. Space at the end didn't work right because okay. Never mind. It read until it didn't So what was happening with the space at the end? When we put the space at the end of the part here, is it read until it found something other than a white space character. And it doesn't matter how many times you hit the return key, that return key is still white space. And so I had to type something other than white space. When you put it in the beginning here, it'll skip all white space until it finds something, and then it'll do the next line. There's the print hello. Now we can say something like x equals 3, print x. If we mistype print, it'll tell us the string per 34, attempt to call a nil value per, global per. That's the error that we have there. Print 34. So now this is the more fully featured version. Does this look like an interpreter yet? What would make this look more like an interpreter?
String prompt.
So some sort of prompt for the input. So how do we put some sort of prompt for the input? We can printf something here. Okay. Then we have that caret down there on the bottom, and we can say, for example, print hello. So that we had that extra, we fucked up on the extra in there. So we can't type up because we don't support that. There's the hello. I can't hit the up arrow. Why can't I hit the up arrow? Because I haven't programmed that in C yet. Whose responsibility is to program that in C? That'd be mine. Does this look suddenly more like an actual interpreter? That could almost be Bash if we made it look more like Bash. You can print out a bunch of information. That's all the C code that it requires right there. To make something that looks like Bash. Or something that looks like an interpreted language like Python. If you're used to programming in Python, Python looks something like that. Python has some C code on the back end that looks something like that there. Python's a little bit more involved, but that's essentially the basic idea. Yeah, so the header files have a lot of information. Like when we looked at the doString there's a bunch of stuff that helps us inside of the doString. That doString is a big one. What other things would we want to look at? So what we can do now is whatever Lua can do. So for example, if Lua knows how to open files, we can use Lua because that's built into Lua. We're done as far as implementing Lua things. The problem is that if we want to make Lua do more things that Lua can't currently do, we have to implement that ourselves. And that's one of the things we'll talk about moving forward as well. But for now, that's our basic intro into interpreters and how Lua works. These are now two languages working together, C and Lua. Your assignment will be to do C, Lua, and Bash, and have all three of those languages working together.